Okay, my friends, another exciting day. I've been going against the standard model for 50 years or more because it doesn't work, because of this big gigantic positive core and little tiny negatives. Cannot work. Everything is a dipole. Now, they're just trying to cover themselves and trying to make this standard model work. It does not work. It's never going to work. They got to give it up. They just fired up the Large Hadron Collider again. This is just today. They're saying, we found all these big particles, these record-breaking precision and all this stuff. Well, guess what? Here's what they're still saying it's based on, is this, which is the standard model. All right, you see all these particles? Up and charm and top and down, the strange and bottom electron, muon, tau, neutrinos, W's and Z's and Higgs. Now, I could show you all these particles, but they all emanate from two particles, the electron neutrino and the muon neutrino. That's all there is. That is all there is these two particles. That is all that exists. When you add them together, they're like little bar magnets. And you add enough of them together, you start to make atoms. Then you start to make molecules. Then you start to make matter. But when they're in this configuration here, they are electricity. Two of them together is really literally an electron, what we would always consider an electron. All right, because this is the glowy, smashy part, and this is the, has no energy. This is hard to explain. Let me show you the particles. But remember this, these are the only two that exist. And from these two, everything else comes. Okay, so troubling, inconsistent results. Well, guess what? Standard model is just wrong. It's literally impossible. And anybody that has a mind to think can understand you cannot have a gigantic positive core and little negatives. It would just do that. Anyway, they've tried to justify this, and I tried to do the same thing since 1968. It's impossible. Now, they say after years of trying to poke holes in the standard model, which nobody would listen to, poking the holes into it, which there was plenty of holes to poke, researchers recently published a compelling backlog, which is all these evidences that always existed, of evidence that suggests previous estimates of the W-boson mass may actually be wrong. If these findings are further confirmed, it would suggest that the entire standard model may be wrong, which it is. I've shown you all this stuff, or I will. All right, so here is my claim, that instead of a proton being one big positive particle, and that they can smash into little bits, and they find these little bits, that whole slew of particles they had. Well, guess what? When they smash this apart, what's inside is literally this. And every one of these is a particle. And there's, I believe, 1,839 or so in a proton. Each one of them is an electron. All right, that's an electron. Two of these, this white and this black together is an electron. This is another electron. Whoops, see, they gang together. They try to get together, that's why. They get together right there, and then they become basically neutral. When they're on their own, they're powerful. But when they come together, they become a neutral particle. Watch, see that? Zip, and they just fall down. So that's what happens. They bounce. Light bounces. Electricity burns you. Electricity will burn right into you because it wants to be incorporated into something. All right? But whenever you have two of them together, they won't burn you. They will just bounce away from you. That's what light is. Electricity is one of these. So don't forget, that's what a proton is a ball like this, not a ball like that. And you can easily understand this because hydrogen is supposed to be one big proton and one tiny electron. And guess what happens when you explode hydrogen? It's the most explosive thing you could ever imagine. Well, what's going to blow up if there's just one big chunk here? That chunk blows up. And what does it blow up into? Every single electron becomes a powerhouse on its own. And the explosion is just unbelievable from hydrogen and oxygen. And what is hydrogen and oxygen? Water. I say we can run things on water. All we need to do is be able to divide it correctly, and then let it come back together. Let me show you what water can do. So once again, I say this is the electron neutrino and this is the muon neutrino. The muon neutrino is a fixed particle, as Fermilab has also said, and this is the white one is the point particle. Again, half is an electron, the other half is an electron. As it moves through the air, the one that is forward and concussing with all the particles that are in the air will start to glow. You see it glowing here? It's building its glow. And eventually it will flip. And this one will come to the front and that one will go to the back. Now they may call that the upspin, downspin, I don't really know. But I can tell you what, these two particles make everything there is, and we can separate them, and I can show that. And it's exactly what CERN and Fermilab are looking to do. And they're trying with protons, which are these gigantic particles, and they're digging literally through debris. We started with light. So we started with the black and white ones together. We separated them because we used a Venturi to crush the fields instead of hitting them head on. Head on is not the way to do it. It's to force them into each other so that it's the Feynman type of way of doing it. Feynman saw it happen. He had no way to do it. We did it with a Venturi. Feynman just saw it happen and realized we're getting these double bosons and all these things are coming out of this collision of photons. Well, we collided them because we knew how to do it with a Venturi, and then we made the Venturi so tiny that only the white ones could get through, the black can't. Complete separation of powers. All right, so it is a complete separation of powers. There's your muon neutrino. These are the only two that exist. The black and the white ones, as I showed you. Think of a photon, or actually an electron. Think of an electron. That's the electron right there. There's a black ball, which is this one here. It never does anything other than it stays the same size, and it's hard as hell, and it's almost all the weight of the particle. This is a little fluffy jobber, and it's like this. Look, it almost does nothing. That's the difference between the two. And you see that in an atomic bomb blast. If you look at slow motion, you see the white ones come, and they hit the buildings, and the buildings just burn. It doesn't go anywhere. A second later, these come, pow, the building goes flying. It doesn't burn anymore, it just goes flying. So I've shown this stuff so many times, it's getting a little old for me at this point, and I'm getting a little old doing it too. It's been many years now. So we separated, that's fission, that's fusion. This is, I don't know what. It's an electron shower. Now, what happened to that electron when it got into this mode? It's totally separate. It seems like there's a hell of a lot of energy. They say it's 200 and something times more energy than you started with, and I can believe that. Now, let's see if we can see all these other little particles that they're seeing. We're using light. Now, they're seeing these tau leptons, and because right here, this is your bosons, and well, here, hold on. I'll show you the Higgs. All right, so that's a little demonstration for you how when you split up atoms into their littlest bits and pieces, you end up with electron neutrinos and muon neutrinos, and when they split up, they really split up. Now, I showed this the other day. This is Alex Smith and this hydrogen-oxygen balloon explosion, and it's a teacher showing the kids. Now listen to what he's doing here. No, here's what he's got. He's got some gases in here, not completely hydrogen. He's got some other gases in there, but there's a lot of hydrogen, but not a ton. Not like when I show you just a complete hydrogen. So, all right, see him sort of flame up. Well, that's all wonderful. Well, they like that. Well, guess what? Well, you see this. Now, you see what he's got here? H2O2. That's hydrogen and oxygen. That's nothing more than water. And when you have them in a gaseous form, it's a different story. So my claim is that instead of being filled with balls like this, it is filled with balls like this. And when he explodes this, the balls that were supposed to be like this, that are really like this, explode. Every one of them turns into a ball like this. All right, what's this going to do? I can't do any big explosion. This can, because there's not enough of them that when you hit them with a spark, they say, okay, let's all get out of here, and they all go at the same time. And I mean they go. Now, he tells these kids to open their mouth so that their eardrums won't blow out, and they think he's being funny. He's not being funny. Listen to this. You see that? That's water. That's water from the hydrogen and oxygen combining in that pressurized explosion. And the kids love it. Alright, this is a whole batch of them at once. That's just light coming through as a pulse red laser. That's a pulse, 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 pulse. And each one of these has one of these particles, you know, coming forward. This is a leader, so it's really glowing because it moved everybody else out of the way. These have to glow too because they're pushing them. Anytime you push a magnetic field against another magnetic field, you get radiance and luminosity. And that is what we are picking up. We're not using any special instruments to affect any of the interaction here whatsoever. We're not using sensors or electronic devices. We are looking at the luminosity. And that is what's done with the CMOS smartphones. This is a smartphone. And they use it to detect cosmic radiation, and they've been doing it since 2014, so don't tell me we can't do it. And the only reason we can do it is because of luminosity. You can't just take it up and pick up, oh, let's take a look at electrons. No, obviously. You have to have them glowing. And you can see, right, there's nothing there, absolutely nothing, and nothing here. Because this is where the increase in energy is starting to occur. These are all over here. You see this field? There's more of them, they're everywhere. The only reason these are glowing is because of the explosion coming back at them. All right, look. And these are the Higgs fields over here. We'll get that in a second. But here, because these are all Higgs fields too. You just don't see them. You see that? That's only glowing because this is coming back at it. That's coming back and hitting in the front of it. This is a glowing because it's coming forward, and these particles are accelerating, and they are smashing here, dividing, and recombining here to black and white. And that's this wave right here, and this particle stream is this particle, as I showed you before, I believe. And it glows, and there's a black one and there's a white one. The white one glows and gets small and big, and the black one just does not do anything other than smash the hell out of things. These are the Higgs fields. And how do they develop? They develop from this hazy white glow that's coming through here, which is the electron shower. You can't see it, it's an electron shower. That's this here. You see right through it basically, but it only makes, see how I'm a little blurry looking, glowy looking? And then all of a sudden, bam! This is where the Higgs fields, the God particle, re-establishes itself into reality. And this is where this particle, whatever it is or whatever happens here, I don't know, this glowy spot. At that point, you see these little streamers coming out? That's these streamers here. They just got smacked. And they take right off. That's what the Higgs fields are. And again, we're working with light, so we're not working with any gigantic particles. Now, this one here, that baby there, that is a mind bender, because that's the only one I've ever seen, and I think it came in backwards. You see this white one? And it looks like it concussed right down here with another one of these fields. So there's a lot to look at here. And the green is the same as the red. And here, let me show you something how the red, here's the green. Same stuff, only these are hot. These babies come in fast. And I can show you that too, because we have them in the same shot, both of them at the same time. Well, let me just show you that so we get that out of the way. Green and red at the same time. Here they are. You see it? The red is just dull. Look at it. It's just there. Poof. The green, pew, get out of the way, red. And then it reconcusses out here. Same particle though, you see it? This was a different style phone. Rod was using the Samsung Galaxy S3, same as I was using here. And he still uses it because it's stunning. It's from 2012. That was their, well, anyway, I like it. Now, oh, here's Fermilab. That's exactly what they show. You see the black one here? That's this one, a fixed particle. A glowy thing around, a glowy thing around. I mean, there is no difference. And the white one is the point particle. That's this one here. And the two of them together make the particles that fill space, because these particles are light. And even this is also at CERN, Fermilab. I think CERN might be too. But Don Lincoln at Fermilab says these are the particles that exist, and I agree. And he also says that the particles in space that exist are what we would call a quantum foam. And that's what these are, because they're just spinning through space looking for a space to bang into. And if you're sending light from anywhere else, it's coming through these particles. That light's going to slow down. So we got a problem with Hubble. We got problems with Einstein. Because I can speed up light and I can slow down light. And I just showed you that. All right, I showed you the red, I showed you the green, and I showed you the red splitting, and I showed you the green showing exactly the same characteristics. And I can show you the green splitting too. Now, the blue, you see it's coming in hot here, real zzz, and it slows down. Well, it's spinning to the right. That makes it drift to the left. Because this picture is the same shot of all of these at the same time. It's the same particle. And we took the picture of the whole thing. So I'm showing it coming in hot, slowing down. So obviously it can slow down. And I showed the other one, I believe it was speeding up, which was the red particle. Now, the red part, whoops, I'll save it, yeah, why not? And the red particle actually, hold on, let me find the red particle, red, here we go. Now, what is going on with the red here? You know how they're talking about tau leptons and this and that, and muons and Z's and W's, and, well, the first thing that happens with light is it comes in and sort of, I don't know what it looks like until it starts to display itself, to be honest with you, because there's light up in here that's just not shown. It doesn't have enough luminosity for us to see it. The only reason we can see this is because of that. And what is that, Roger? Well, that's the Venturi. And well, what does that do? It forces these glowy little buggers to crush themselves into their own fields. And I believe the big black one here acts like a jackhammer. They can't get through this slit. Think of this. We have a slit here. Let's just think of it this way. There's a one here and another one here. And they can't get out of here. They can't get out of here. When they hit that slit, something's going to happen here. The black ones can't get through. The white ones can. So the white ones collect up here, and the black ones, bam, 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 bam. Because these are pulses, pulse, 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 pulse. Doo, 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 doo. And these black ones, every time they hit, it's just like that against those white ones. And the white ones are almost nothing. So I believe that's why they're squirting through that Venturi over there so violently and creating that separation of powers. Now, did they call this a different particle than that? I don't know, but I call everything made out of the black and the white particles. That's all that exists. And when you add two of them together, you have an electron. You add two electrons together, you have a photon. After that, it's nothing more than little bits and pieces of these added together. And then you get up to the first basically stable ball is going to be a hydrogen. And that's what the core of a hydrogen is going to look like, a round ball basically of particles. But they're all electrons. And then you start to add more and more and more and more. You start to get your elements. And the periodic chart's not right now either. There's so much wrong, it's unbelievable. You cannot have the Bohr model. It does not work. And once you get away from the Bohr model, not a single thing is correct. Nothing. So some of the conclusions you can draw, yes. Once you get into the molecular range, when you're outside of the subatomic range, things seem to work pretty good. There's going to be a lot of changes, and a lot of them are going to relate to biology. I can tell you that right now, because biology works with so much of this. When you see, if you know what nucleophilic reactions and substitutions are, and enzymes and catalysts, and all of the proteins that are working in your body, that are literally, completely, and totally from bacteria. All of those enzymes and catalysts and every function in your body, not one single thing in your body happens that does not involve bacteria. Not a single thing. Zero. Zero. Nothing. Nada. Every single biological reaction in your body, which is from your health to digestion, the way you poop, the way you walk, to how you feel, is completely 100% dominated by bacteria. They make the catalysts, they make the enzymes, they make the proteins, they make the food, they take out the waste, they do everything. You are a place for them to live. All right, here's the issue with the big colliders. They're using protons. Now, I showed you what a proton is. Literally, a proton is that. Not one big ball like this. It's that. So when they collide, literally billions of these head-on, of these particles, they just have debris. This is exactly what they say. It says to produce an elementary particle, which are these particles, the littlest bits and pieces. We started with light, so we didn't start with this. We started with that. So, and then we split that. So they say to produce these elementary particles, that's all they're looking for, is the smallest one they can find, such as top quarks physicists smash together subatomic particles, known as protons, which they think are these, which are actually these. In devices such as these large hadron colliders, they come head-on, bang together like that. Each collision results in a range of other particles being spat out like debris, allowing researchers to study these byproducts in a controlled environment. So they look at them and they see them, and they say, ooh, look at that little white one, ooh, look at that little black one, ooh, look at those little black and white ones together, ooh, look at this 4 of them, ooh, look at this 6 of them, you know, and then they keep throwing on new names to these things. They're made out of the same 2 particles. It's still tricky to actually observe. No, it isn't. Each particle's properties. No, it isn't. We can see them. I can see how they collide. I can see how they grow in energy. I can see how they split and divide. When we start talking on these incredibly small scales, which are luminosity, we enter the quantum realm, exactly where particle becomes a little fuzzy, yes it does, and it's tough to pin down exactly what their mass is. I'm not calculating their mass. Well, you might be able to calculate their mass, but I'm just seeing it as the white one has almost no mass at all, and the black one has literally all the mass. And I will show you that right now. Okay, my friends, I'm going to leave it at this. I just showed you those 2-point particles. That one was the burner, came first. That one was the exploder, came second. This is Fermilab's, not mine. This is from Fermilab. And they say it's fixed. That's the fixed one. They say it's the point. That's the point. That's what it is. And I showed them, and I showed that they can separate from each other, which they did in the atomic bomb explosion and in our subatomic bomb explosion, because that's exactly what that is. It's fission and fusion of the muon neutrino and electron neutrino, and that you don't get any smaller than those, I don't think. There's another shot with a brick house. Boom. Now you see everything. You still got smoke. You still got burning, even though they're bricks. The roof goes. All the wires smoke. Everything that can smoke smokes, but nothing moves. Look, it's just smoking. Boom, there it goes, and then zip, there it goes, it turns back. Alright, a lot of people don't know how atomic bombs are made, but they're made with extensively heavy particles that have so many particles that they're just barely staying together as it is. When these explode, what they do is they force everything in to the center, and then it all pops back out with unbelievable pressure. And it does because all the white ones go first, and then the black ones follow it. If you were to see what a nuclear bomb really looked like, it would be just like this, a ton of white glowy particles surrounding a dark core. And then when you crush them in, they all go, and then the dark core starts to follow. Not the dark core in its entirety, the particles from the dark. So the first particles to leave are the white ones. And they light everything up and burn. But they don't move anything. They don't weigh anything at all that I can tell. And then the black particles that are about the same size follow them. They knock the house down. And then because there is no more white particles back at where the first thing started, and most of the black particles are still there, they want the white ones back. Everything turns around and comes back. Watch, and I shall demonstrate. This is almost a mile away from ground zero, 4,700 feet. Here it goes. Now you see, I just stopped it. You see what's happening here? It lit up brilliant, and all it's doing is smoking. Smoke, 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 smoke. Boom. Now watch it turn around. You see everything turn around and come back? That's because of the reaction I just told you about. The black core back at the beginning of the explosion wants those guys back, and they come back. I'm going to make one last request. Talk to your physics professors. Talk to anybody that's in government. Talk to Don Lincoln, Fermilab, CERN, University of Geneva, anybody that's doing these particle physics, anyone. And there's thousands of these people that's just literally walking around in circles because they never knew where to start. All they're doing is repeating what they were told to say and then trying to come up with all these little doodles and mathematical formulas to force what isn't real into their theory, which is the Bohr model. It doesn't work. The standard model absolutely does not work, never can work. It's impossible. You cannot have a big solid positive and little tiny negatives surrounding it. Totally impossible. And it doesn't solve gravity. Nothing works in the standard model. That's why they have to keep trying to defend it, and they can't. They can't defend it. All they can do is say, we're the experts, get lost. We're doing the science. And that's exactly what they told me. We're the experts. You're nothing. You're a tinfoil hat guy. That's what was the words that came to me from these physicists. You're not peer-reviewed, so get out of our realm. Basically, that was it. And that, I am not going to go. And I'll do this 10,000 times. Sooner or later, they're going to say something, and somebody's going to stand up and say, hey, you people are just eating our money up and just eating our lunch. and having a good time laughing at everybody else. And that's what's happened. I've been laughed at for many, many, many years. And I have been correct. And it's time to unlaugh.